B, C, D, right? I'm going to say this area here is equal to the area of the whole thing, A, B, C, minus the area of this piece down here, A, B, D. That's convincing, right?
Mm-hmm.
Take area from area, you get area. Yeah. So how do you find the area of a triangle? Carefully, yeah. And where are my angles here? Well, I guess if this is alpha here, or should we make this one beta? And this one alpha? And this one is alpha plus beta? And the area of a triangle is the height times the base, right? So I'm going to draw a perpendicular from here to here. Is that convincing for the perpendicular? I'm going to put in the whole right angle indicator. And I want to say something is 1. Which can make equal to 1? The hypotenuse, the base, hypotenuse? How about the base? I think it should work out no matter what I do, right? So this is 1, that's 1. Well, the hypotenuse might be convenient, right? But it should work out in any case. Okay, so if this is 1, and this is alpha, then AD is equal to, well, I got cosine of alpha is equal to adjacent over hypotenuse, right? So that's going to be 1 over AD. Yeah. And from here, I've got, do I want cosine of alpha plus beta? Maybe. I guess I want to name this point too, right? We'll call that E because that's the next letter in the alphabet. And so the height is going to be DE, which we know that AD is equal to secant theta. Sorry, secant alpha. Right, the reciprocal. So I don't know, maybe I'm doing this wrong. I'm worried. Secant alpha. So what is AC? All right, so just start writing down things that you know until it pops out. That's the approach here. So what do we know? We know sine of alpha plus beta is going to be opposite. Oh, cosine. Cosine of alpha plus beta is going to be adjacent over hypotenuse, so that's going to be equal to 1 over AC. Yeah. Okay. And so what's the area of that triangle? Well, we need to get DE somehow, right? And DE has a hypotenuse of AD, so we can say sine of beta. I'm worried about this. Maybe, there's probably an elegant, quick way of getting this. I'm going to be thrashing around like a shark in the net or something. So that's going to be ED over AD. Okay, well, we know that AD is equal to secant alpha, or 1 over AD is cosine alpha, right? Am I right about this, first of all? Sine of beta is opposite over hypotenuse, right? So the side opposite in the right triangle ADE, the side opposite beta is ED, right? The hypotenuse is the opposite right angle at E, that's AD. So this is correct, right? And so that gives me a formula I can solve for ED. That says that ED is equal to AD, which is secant alpha. Secant, huh? No, we don't have secant in our. Secant is the reciprocal cosine, so it'll all work out. So that's going to be 1 over. Okay, yeah. So ED is going to be AD times sine beta, right? So that'll be secant alpha times sine beta. All right. Okay. So what's the area of triangle? So this is one way of writing the area, right? Area of triangle ACD is equal to 1/2 base times height. The base is AC. Do I have AC here somewhere? I guess the base is going to be AC, which is going to be secant alpha plus beta. Okay, so I'm going to write 1/2 base times height, right? The base of that triangle is AC with respect to the height ED, right? So that's the altitude on the base AC. And so we've got AC is secant alpha, and ED is, so we're going to have secant squared alpha? Looks like it, huh? Since ED has also got a secant alpha in it. Okay. Secant squared alpha, so be it. Times sine beta. Okay, how about the area of this triangle? Well, this is easy, right? This is the right angle, the altitude is, so this is the area of triangle ABC, and that's going to be 1/2 the base times the height BC, and what's BC in terms of alpha and beta? Oh, well, I guess we could write tangent. Tangent alpha plus beta is going to be BC. Should we write that down here? Tangent of alpha plus beta is going to be equal to opposite over adjacent, right? So it's going to be BC over 1, and that says that BC is tangent alpha plus beta. So this will be the height. Okay, I got that one. I don't know. We'll see. How about this one? Well, same thing, right? I can say tangent alpha is equal to dB over 1, right? So the area of triangle ABD is going to be equal to 1/2 the base, which is 1/2, times the height, which is tan alpha. So let's put it all together and hope for the best. We're hoping that one of these pops out of here, right? We do have, tangent of the sum involved, and we've got sine and cosine of alpha and beta involved. So I'm hoping for the best. So what we're going to write is that the left side, which is the area of triangle ACD, which is going to be, and they all have a 1/2 in them, don't they? Can I just multiply by 2? Well, I'll save that. Okay, so we've got triangle area of triangle ACD is going to be, let's write it here, 1/2 secant squared alpha sine beta. And that's equal to the area of triangle ABC, which we wrote as 1/2 alpha tan alpha plus beta. subtract from that the area, triangle ABD, which is 1/2 tan alpha. Okay, so let's write these all in terms of sine and cosine, right? And hope for the best. I'm not terribly optimistic, because that tan alpha plus beta doesn't look good, does it? It's going to have both a sine alpha plus beta and a cosine alpha plus beta. And here we've got, so let's multiply it through by 2 and have sine beta over cosine squared alpha. And that's equal to sine alpha plus beta over cosine alpha plus beta minus sine alpha over cosine alpha. Right? So that's just switching all these three functions in terms of sine and cosine. And it looks like we could multiply through by cosine squared